evening, everyone. So, what do you think are the factors that affect the spread of fire? Do you have any idea? If not, then allow me to share my gathered knowledge about the five related topic. For better understanding, please consider these relevant information that I'm about to share with you. There are three factors that helps or aids to spread the fire. First, we have the weather. Weather, it includes relative humidity, air temperature, and wind. Warmer temperatures and lower relative humidity make the fuels more receptive to ignition. Stronger winds supply oxygen to fire, preheating the fuels in the path of the fire and transport embers ahead of the flaming front. When hot, dry, and windy conditions occur simultaneously, fires can spread quickly. Second is fuel. It includes fuel load, fuel moisture. So first, fuel load. Very low volumes of fuel can result in a low intensity creeping fire. On the other hand, large volumes of fuel could result in a blow-up fire that is difficult to control. The more fuel burning, the more heat produced. Fuel moisture. Fuel moisture strongly influences fire ignition potential and flammability. The drier the fuels, the easier they are to burn. Fuel moisture is also an integral part of predicting fire behavior and fire spread probabilities. Lastly, we have the topography. Topography is the most stable variable in the fire behavior triangle. Slope, aspect, elevation, and topographic features influence fire spread or how fast a fire moves in feet per hour. For example, fires tend to spread faster up a slope than down one. Next topic is spontaneous combustion. So what is spontaneous combustion? It is the ignition of organic matter, example, hay or coal without apparent cause, typically through heat generated internally by rapid oxidation. It doesn't require any external energy to start the combustion process. This reaction starts because of internal oxidation in the substance, which leads to a thermal process. If that particular substance reaches its ignition point temperature and has enough oxygen to start the combustion process, the substance starts burning on its own spontaneously. So these are the examples of spontaneous combustion. Number 1, forest fires. Number 2, phosphorus burns spontaneously at room temperature. Number 3, the reaction of alkali metals when combined with water. Number 4, bacterial composting inside organic materials. Number 5, many accidents in coal mines are due to the spontaneous combustion of coal. The next one is the most interesting and the most risky part of this video, the dangerous behavior of fire. So fire is so fatal when the following conditions occur. 1. Backdraft. It is the sudden and rapid or violent burning of heated gases in a confined area that occurs in the form of explosion. This may occur because of improper ventilation. If a room is not properly ventilated, highly flammable vapors may be accumulated such that when a door or window is suddenly opened, the room violently sucks the oxygen from the outside and simultaneously a sudden combustion occurs, which may happen as an explosion, a combustion explosion. Number 2, flashover. It is the sudden ignition of accumulated radical gases produced when there is incomplete combustion of fuels. It is the sudden burning of free radicals which is initiated by a spark or flash produced when temperature rises until the flash point is reached. When accumulated volume of radical gases suddenly burns, there will be a very intense fire that is capable of causing flames to jump at a certain distance in the form of fireball. Fireballs can travel to 100 yards within a few seconds. As you can see, the fire is burning in the corner of the room, and as the fire begins to grow, it pumps more and more heat and flames and smoke into that overpressure above the fire. This is really important because as that smoke layer begins to heat up, they get closer and closer into the auto-ignition temperature until a point where everything in that room catches on fire about the same time. Number 3, bite back. For the bite back, we were not able to create a video demonstration because it's too risky since the fire is pacifiable, and of course, safety first. So what is bite back? Bite back is a fatal condition that takes place when the fire resists extinguishment operations and becomes stronger and bigger instead. Number 4, flash fire. Flash fire is better known as dust explosion. This may happen when the metal post that is completely covered with dust is going to be hit by lightning. The dust particles covering the metal burn simultaneously, thus creating a violent chemical reaction that produces a very bright flash followed by an explosion. A flash fire is a sudden, intense fire caused by ignition of a mixture of air and a dispersed flammable substance such as a solid, including dust, flammable or combustible liquid such as aerosol or fine mist, or a flammable gas. It is characterized by high temperature, short duration, and a rapidly moving flame front. A flash fire ignites when oxygen and fuel mix together and come into contact with a heat source that sparks the fire. These conditions create a flame that is characterized by high heat temperature and rapid movement. Heat versus temperature. Heat should not be confused with temperature, which is the measurement of the relative amount of heat energy contained within a given substance. Temperature is an intensity measurement with units in degrees on the Celsius or centigrade, Fahrenheit or Kelvin scales. Heat is the measurement of quantity and is given in British thermal units BTU. Temperature is the measurement of a degree of thermal agitation of molecules, the hotness or coldness of something. Thermometer is the instrument used to measure temperature and commonly expressed in degrees Celsius, degrees Fahrenheit, and Kelvin. Although it is very easy to compare the relative temperatures of two substances by the sense of touch, it is impossible to evaluate the absolute magnitude of the temperature by subjective reactions. Adding heat to a substance, however, not only raises its temperature, causing it to impart a more acute sensation of warmth, but also it produces alterations in several physical properties which may be measured with precision. There are 3 ways to transfer heat. First is conduction, convection, and radiation. Conduction. So what is conduction? It is the transfer of heat by molecular activity which in a material or medium, usually a solid. Direct contact is the underlying factor in conduction. Example, if you touch this pan handle here, the pain you feel is the first result of the conducted heat passing from the wood-burning stove directly into our hand. In a structural fire, superheated pipes, steel girders, and other structural members such as walls and floors may conduct enough heat to initiate fires in other areas of the structure. Number 2, convection. Please refer to the video above for the demonstration. Convection, it is the transfer of heat through a circulating medium, usually air or liquid. Heat transfer by convection is chiefly responsible for the spread of fire in structures. The superheated gases evolved from the fire are lighter than air and consequently rise. They can and do initiate additional damage. In large fires, the high fireball that accompanies the incident is referred to as a firestorm and is an example of convected heat. In our illustration above, the boiling manner of the water making the particles move vigorously is an example of convection. Number 3, radiation. Radiated heat moves in wave and rays much like sunlight. Radiated heat travels the speed as the visible light 186,000 miles per second. It is primarily responsible for the exposure hazards that develop and exist during a fire. Heat waves travel in a direct or straight line from their source until they strike an object or a person. The heat that collects on the surface of the objects or building in the path of the heat waves is subsequently absorbed into its mass through conduction. For example, if you go near the fire, The heat waves travels directly to its surrounding until they strike any objects or any person. That is why even though we are not touching the fire or the handle of the pan, we can feel the heat radiating into our body, which makes the temperature warmer, also our body warmer. In conclusion, conduction requires a physical contact between the bodies or the portion of the bodies exchanging heat. Example, the handle of the pan and me. But the radiation does not require any contact or the presence of any matter between the bodies. Convection occurs when a liquid or gas is contact with a solid body at different temperature and is always accompanied by the motion of the liquid or gas. The science dealing with a transfer of heat between bodies called heat transfer. The physical methods or by which an energy in the form of heat can be transferred between bodies are conduction and radiation. A third method which also involves the motion of matter is called convection. That's all for today's video. Thank you for watching and keep safe.